Okay, so in this video, I'm going to go through the solutions to homework number 9, which is primarily um, graphing piecewise functions and some other basic functions. Okay, so let me just hide that floating panel there. All right, so the first question is in number 1 is the piecewise function x squared plus 1 for x less than 0, and then x minus 2 for x greater than or equals 0. All right, so we're going to start with this value. No matter what it is and whether it's equal to or not, we're going to put this in for x. And 0 squared is 0 plus 1 is 1. Another number less than 0 is negative 1. Squared is 1 plus 1 is 2. And then negative 2 squared is 4 plus 1 is 5. And again, I'm putting all these values here in for x. Those are my inputs. The next piece, I'm still going to put 0 in. Obviously, it is included, but I will still put 0 in for that. You get negative 2. Substitute 1 in and get negative 1. And substitute 2 in and get 0. I just sort of did something I normally don't do. I usually graph 3 at a time, but it's okay. So let's graph these 3 up here. 0, 1, and that's going to be an open circle because there's no equal to included here. So at that point, 0, 1, 0 is not included, and we indicate that by an open circle. Next is the point negative 1, 2, which takes me up here, and then negative 2, 5 up here. The important part, we are graphing an x squared, and we all know by now that shape looks like a parabola. First, this is where I started from, and this is where I'm going. So I'll connect it like a U. This bottom half down here, 0 is negative 2, kicks me down here, but with the closed circle. And then 1, negative 1 is here. That's obviously also closed. They're all closed, because they're all numbers greater than or equal to 0. And then 2, 0 here. So there I am. And that is a line. It's mx plus b. This does make sense. The slope, don't forget, is positive 1. I could have also taken from this point up 1 and right 1, because that's the slope of the line. Notice how this graph passes the vertical line test. There are no overlapping pieces. Okay, another one is B. F of x equals 2 minus x squared for x less than or equal to 1. And it's the square root of x for x greater than 1. Again, I'm going to substitute 1 in for x, and 1 squared is 1, and 2 minus 1 is 1. 0, I'll pick, it's less than 1. 2 minus 0 squared is 2. And then negative 1 squared is 1, but 2 minus 1 is 1. I guess I'll come down here and still pick 1, even though it's not equal to. We're always picking this number, however the domain is broken up. This domain is broken up at 1, and we have to substitute that number in. So the square root of 1 is 1. And I'll pick 4 because the square root of 4 is 2. When I go far out, the square root of 9 is 3. And I'll graph those points. So we're going to go over 1, up 1, but it's going to be a closed circle. 0, 2 is right here, but negative 1, 1 is here. And this is where I started, right here. And this is where I'm going towards, right there. It should make sense. We want to pause and reflect. Does our work make sense, and does it support what we know? It's a negative x squared. A portion of that graph should look concave down. This next piece is 1, 1. So this often is questionable. Does the circle open back up? No, because when your input is 1, your output is 1, you're just getting that value from the top half. So this circle remains closed. And then I'll just go over 4 and up 2. And I think I have enough to realize that's the shape of a square root function. Let's take a look at another one here. I guess part C. F of x equals the piecewise function 1 minus 2x for x less than 1, and it equals x squared plus 1 for x greater than or equal to 1. So a lot of things broken up at one of these. So we're going to take 1 and substitute that in, and 1 minus 2 is negative 1. I'll pick 0, that's less than 1, and 1 minus 0 is 1. I'll pick negative 1, but be careful. Negative 2 times negative 1 is 2, plus 1 is 3. And again, we're putting these all in for x. Down here, I'm going to substitute 1 in. 1 squared is 1, plus 1 is 2. I'll pick 2. 2 squared is 4, plus 1 is 5. And I think I'll have enough points for that. I mean, I could, of course, pick 3, square it to get 9, and add 1 to get 10. It's very important to get those outputs correct, because if these y's are incorrect, your graph will not connect to give you the right shape. So 1, negative 1, that's going to get an open circle because that 1's not included. And then 0, 1. Oh, wait, I graphed that wrong. 1, negative 1. See, 1, negative 1 is here. And then 0, 1 is right here. And then negative 1, 3. And that's okay. Now, this is where I started. That's that very first point. This is where I started. And this is the direction I'm going in. All numbers less than 1. Now, when I graph this one, 1, 2, and then 2, 5, I know this is a positive x squared. The leading coefficient is positive. It's a portion of a parabola concave up. And there it is at that point right there. Next up is D. F of x, a little different, equals the piecewise function, the square root of negative x for x less than 0. And it equals x squared plus 1 for x greater than 0. All right. So I'm going to pick 0 and substitute that in, and the square root of 0 is 0. I'm going to pick negative 1 because that's less than 0. When I substitute that in, that negative times that negative is a positive, and the square root of 1 is 1. And I'll pick negative 4 now, because this negative 4 times that negative 1 on the inside gives me positive 4, and its square root is 2. When I come down here and pick 0, 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. And then 2 squared is 4 plus 1 is 5. This time 0 is not included in either piece, so they'll both get an open circle. So 0, 0, negative 1, 1, and negative 4, 2. So what happened, well, I didn't go up far enough maybe. This is where I started. This is where I'm going. Does that graph make sense? Yeah, it's got the shape of a square root, which looks like this, but it gets reflected about the y-axis because the inside is negative. So it reflects it about the y-axis. Over here, 0, 1, again, another open circle, and then 1, 2, closed, and then 2, 5. I can just envision that. And again, a portion of a parabola concave up. This time 0 is not included at all, so they're both open circles. So 0 is not in the domain. Part E, a little twist on things. We've got a middle piece to worry about. So, but pretty simple, 2 minus x for x less than 2. This middle piece is 3 for when x equals 2. And this bottom piece is x squared minus 2 for x bigger than 2. So the top piece, start with 2. Put this in for x, and 2 minus 2 is 0. I'll pick 1 because that's less than 2. And 2 minus 1 is 1. And then I'll pick 0, which is obviously less than 2. And 2 minus 0 is 2. This is different. This is an ordered pair. This means when x is 2, y is 3. And that will be a closed circle. Down here, I'll still pick 2. 2 squared is 4, minus 2 is 2. 3 squared is 9, minus 2 is 7. And then I can pick 4 squared. That's going to be pretty big. That's 16. Put the 4 in, that's 16. minus 2 is 14. But wait, what happened here? Okay, so that would be 4 squared is 16, minus 2 is 14. All right, I got a lot of points here to graph. So this is 2, 0, right here, open circle. 1, 1, and then 0, 2. Again, this is where I started. That's this point right here. I'm going towards those points, and there's my line. This is of a negative slope. That's why the line is falling from left to right. This line falls from left to right because the slope is negative. This is nothing more than a closed circle at the point 2, 3. It means when x is 2, I really should go down more for these. That would be the ordered pair 2, 3. So it's closed. It means only when x is 2, y is 3. Only when x is 2, y is 3. In this part here, didn't do the best, but I got enough shape here. 2, 2, it's an open circle. Again, it better be open because it has to pass the vertical line test. And it's just going to be a parabola shaped like that. There it is. Okay. And then some of the problems are old again, are basic functions. Number 2. Part A, f of x equals 2 root of x minus 1. And we're going to do the whole thing. So the vertex is 0, negative 1. So I'm going to go a little faster through here. 0, negative 1 takes us down here. You want to make a table. That's fine. I cannot pick a negative 1. It's not in the domain, but I can pick 1. And if you want, it helps to write out that supporting work rate in that column. So the square root of 1 is 1 times 2 is 2 minus 1 is 1. And then I'll pick 4. And the square root of 4 is 2 times 2 is 4 minus 1 is 3. So I'm going to graph the point 1, 1. And then 4 kind of ends up being a 3. It's a steeper looking square root function. The domain is not all reals. It starts off at 0 and goes to infinity. The range of the y's, it goes as low as negative 1 to infinity. This function is only increasing from when x is 0 to infinity. X's are 0 to infinity. It has a minimum value of negative 1. And I do want to find the 0 of this function to practice some good algebra. So I'm going to add 1 and divide by 2, but then you square both sides to undo that square root. And notice that this looks to be about 1/4. Next part is B. Pretty basic function, guys. It's just an upside down parabola. The vertex is 0, 1. If you prefer to rewrite it with the x squared first, it needs to be made negative as it is. So that better be a concave down looking parabola. So here's my vertex, 0, 1. And again, if you want to make a table of x's and y's, you have to pick negative 1 and 1. You substitute these in for x. And this may help some people to make sure they get those right y values, show that supporting work there. And then just graph 1, 0 and negative 1, 0. You know it's got to be an upside down looking parabola. The domain is all reals because it's a polynomial. The range, though, be careful here, goes from low, that's negative infinity first, to a positive y value of 1. This function is increasing from when x is negative infinity to 0, because it's rising from negative infinity to when x is 0. And it decreases from 0 to infinity. Again, these are only x values, not y's. When we have a maximum value on this parabola, because it's concave down, the maximum will be the y coordinate of the vertex, which is up there at 1. And guys, this is pretty easy. Just set this equals 0 by subtracting 1, divide out the negative, and x equals plus or minus root 1, which is plus or minus 1. In part C, f of x equals negative absolute value of x plus 2 plus 1. Better be an upside down v, right? Because of that negative leading coefficient. The vertex is negative 1, 1. So I'm going to go over what here? Negative 2 up 1. There it is. And then I'm going to make a table. Negative 1, 1. They're both, well, let's try, they're both on the right side. Let's try negative 1 and negative 3. How about that? And this actually might help you make sure you get the right y values, show that supporting work. So this here is 1, absolute value is 1, times the negative is negative 1 plus 1, which is 0. And I know if I substitute negative 3, and I'm going to get that same answer of 0. So it's negative 3, 0, and negative 1, 0. It's an upside down v. The domain, again, is all reals, or negative infinity to infinity. But the range, it's incorrect to say from 1 to negative infinity. Numbers in math are expressed on an interval from low to high. So it starts in the bottom of negative infinity, and it goes up to a y value of 1. The maximum value is indeed 1. It's the highest y value the graph achieves. And what else is there? This function is increasing from negative infinity to negative 2, and it decreases from negative 2 to infinity. Again, this graph is rising from left to right from negative infinity to when x is negative 2, and then decreases from when x is negative 2 to infinity. And those are x's, though, not y's. The zeros, good algebra here, often seen on the SATs as kind of absolute value. I'm going to subtract 1 from both sides. I'm going to divide out that negative, and I'm going to take this inside stuff and set it equal to 1 as well as negative 1. Subtract the 2 to get negative 1. Subtract the 2 to get 0. And there are my answers. Not 0. About minus 3. So here is my 0, negative 3, and there's my 0, negative 1. And one more on this with graphing our basic functions is our good old x cubed. This technically does not have a vertex, but we'll think of it as 1, and that's 0 minus 2. So 0 minus 2. And what else is here? We maybe want to make a table. This always has that same shape. You know, so an x is negative 1. Negative 1 cubed is negative 1 minus 2 is negative 3. When I pick 1, I get 1 cubed is 1 minus 2 is negative 1. So what have I got here? 1, negative 1, and then negative 1, negative 3. So how this gets drawn is this first half where the vertex is, it's concave down first, very flat there in the middle, and then it's concave up. This domain is all reals, it's a polynomial. The range is also all reals, or negative infinity to infinity, because it goes from low to high of all real numbers. What else is there? There is no max nor min. Never achieves a low or a high because it's always increasing. So this function is always increasing for all reals throughout its domain. And then the zeros, a little different here, not rational. I'm going to set this equal to 0, add 2, and you undo a cube by a cube root, and not plus or minus. It's only those even powers, because again, a negative number to an even power equals a positive, as well as a, so that's why it's plus or minus, okay? An odd number, an odd exponent, a negative to an odd power is a negative, okay? So that's why it's not plus or minus with an odd power. Because remember, like a negative to an even power is a positive, as well as a positive to an even power is a positive. But that's not true when the powers are odd. When the powers are odd, it's only that sign. All right, and the rest are kind of old. Number 3 to finish this out. Number 3 is f of x equals 2x squared plus 3x plus 5. Let's find f of x plus h. So that's going to be replacing x with all of x plus h. And this went well in the last quiz, I feel. I'm going to square this. You can either FOIL this out like that, multiply it by itself twice. Remember to just square the first, multiply those two, which is xh, but double it, and then square h squared. And then I'll distribute the 3 through there, and then just clean things up by distributing. And there we go on that. And then number 4, we don't want to forget about lines. So for a line, we always need a slope and a point. For any line, we need a slope and a point. The point we have to pass through, and this is -2, 3. But this line given to us is of the form y minus 3x equals 2. So to figure out the slope I need to solve for y by adding 3x. So now it's of the form mx plus b. The slope of this line is 3, but to be perpendicular, I need its negative reciprocal, which is -1/3, because I want this new line to be perpendicular to that one. To set this up, it's going to be y minus 3 over x minus a -2 equals -1/3. Throw the negative on top. Some people get thrown off when they see the negative here in front. You can put that in the top or the bottom. I prefer the numerator. I'm just here cross multiply to get 3 times y minus 3 equals -1 times x plus 2. I'll distribute and then add the 9 and divide by 3. And there's my line. Okay. And number 5, just again, some older stuff of too good. Factoring, we don't want to forget that factoring. That'll be coming up soon. X cubed minus 8y cubed. Take the cube roots of both, which are x and 2y respectively. The negative in the middle, so whatever this sign is, goes in the middle. Square that x, which is x squared. Square the 2y to get 4y squared, always positive. These two terms are always positive. To get this very middle, squeeze them together, but change the sign. And I think the last one here, number 6, is to solve equations by factoring. Whenever we can't combine these x's, we want to set it equal to 0 and factor. We've got to rewrite it. We have to find an equivalent expression, another way of rewriting things, and that's what factoring does. I'm going to rewrite this as something times something. That's what factoring is. So, I don't know. Maybe I'm going to try just straight FOIL, reverse FOIL. The way I get a 3x squared is a 3x and an x. The way I get a -2 on the end is to have opposite signs, and those are the factors of 2 and 1. But I have to check that I have the right combination. I need a -5x in the middle, and that can't be ignored. And I can see here, this is going to give me 3x, and -2x is 1x. It's not going to work. So I'm going to try a -2 here and a +1 here. And now when I check that the outer is -6x and the inner is 1x, I do get -5x, which tells me I have the right combination because I got that -5x. Now remember, you're rewriting this trinomial as a product. And that's what it means to factor, to rewrite something as a product. So we figured out that this times this gives me that. This times this gives me that. And now I'm just going to set each of these factors equal to 0. That one's done. And then this one down here equals 0. Subtract the 1, divide by 3, and then add the 2. And those are my zeros. 3 zeros for a cubic right there. All right, I hope that helps you with these solutions.